sorry. Now it is approaching to 1 plus sine of 0, 4 times 0 here, which is 1. So we see that it has a forms of one to the infinity, right? So the notes I sent you yesterday, the intermediate power, look at this. Is it of the form 1 raised to the power of infinity? So we may somehow, yes, thank you. We may need to use the L'Hopital rule. Before doing that, let us use the properties of natural log function. Oh, interesting. So look at this. If we define y to be 1 plus sine of 4x raised to the power of cotangent x. So the question would be, how can we compute limit of y, right? This is what we need to do. The same, we just replace it. Okay, now y, instead of writing y, we can write it limit of x approaches 0 plus of e to the natural log of y. Is that okay? Here, we use the logarithmic rule. E to the natural log of y will be y, right? Just a different way to write it. So are you okay with this?
Yes.
Very good. Now, let us rephrase it. This guy, we can write it the limit of x go to 0 from the right-hand side of e to the natural log of y, which is the natural log of 1 plus sine of 4x to the cotangent x, right? Now, which rules should we use?
The logarithmic power rule.
Perfect. Thank you, Daniel. So, therefore, we can bring the power here out of the natural log, right? So it would be the limit from x goes to 0 plus of e to the cotangent x times natural log of 1 plus sine of 4x. Okay? Are we good here? From this, e is a continuous function. at any point of the power here. So the limit theorem that I remind you at the beginning tells us that, okay, this limit will be equal to e to the limit of x approaches 0 from the right-hand side of the power here, cotangent of x, times natural log of 1 plus sine of 4x here. So, is it okay? Do you have any question for me up to this point? Now, the question is the limit of this guy. Now it becomes to this problem. And our job now is to compute the limit here. If we can find it, then we know what the value of this is, right? Let us compute the limit of the power here separately and see what it is. The limit of cotangent of x times natural log of 1 plus sine of 4 of x, okay? Previously, we know that the natural log of cotangent will be going to infinity when x approaches 0. And this guy, it will be approaching to 1 when x approaches 0. This form, it is similar to the forms of infinity to multiply with 0, right? But let us write it another way. Can we write it in terms of quotient? We know that we need to use L'Hopital rule. Okay, what is it in the denominator here?
Is it 1 over cotangent x?
Perfect. And 1 over cotangent x, can we write it in terms of tangent? Very good. But we know that 1 over cotangent will be
Tangent.
perfect. Thank you, Daniel. And Marissa, right?
No, that wasn't me.
Oh, I'm sorry. Who was that? Telling me about the 1 over
It was Carrington.
Yeah, it's Carrington.
Carrington. Thank you, Carrington. Thank you very much, and I'm sorry about the confusion. Okay. Okay. Now, this is 1 and cotangent. When x approaches 0, it is approaches to 0, right? It's somehow like this. So we can use the L'Hopital rule. L'Hopital. This will be the limit when x approaches 0 from the right-hand side of the derivative of the numerator and divided by the derivative of the denominator. Okay? So what is the derivative of natural log of 1 plus sine of 4x here? Anyone help me? I don't remember this formula. Natural log of a function.
4 cosine 4x.
Very good, but let us write it slowly. Ln of u prime, it will be u prime divided by u, right? Which is derivative of 1 plus sine of 4x here, divided by 1 plus sine of 4x, right? Okay. And the denominator, derivative of tangent, give us what? Secant square, right? Okay. Now, the denominator of the denominator, derivative of 1 give us 0. And the derivative of sine of 4x give us? What is it? Sine of a function u, where u is 4x in this case.
Would it be 1 plus cosine u?
Be careful. The derivative of a sum will be the sum of the derivative. And
Oh.
derivative of 1 give us 0, right?
Cosine u?
Yes, it would be cosine of u where u is 4x here. But remember to multiply with a u prime, right? U prime in this case, which will be 4x prime, okay? And the denominator of this guy, just rewrite it. So, and the secant square here. So is it clear for everyone up to this point?
Yes.
Very good. Again, here is a fraction divided by something. So the product rule or fraction rules tell us that, okay, it will be this fraction, which will be derivative of 4x give us number 4, right? So this guy would be 4 times cosine of 4x here divided by the denominator, which is 1 plus sine of 4x here, multiplied with the reciprocal of the denominator, which is 1 divided by secant square x here. Okay? So are we good here? Very good. Or secant square, let us write it in terms of cosine, right? it's easier to see, to find this one in this case. Here it will let us rewrite it. Cosecant 4x divided by 1 plus sine of 4x. Secant. Secant is 1 over cosine square, right? So 1 divided by 1 over cosine square. Can we write it? In terms of cosine? Yeah. 1, right, multiply with the reciprocal of 1 over cosine square, give us. Okay. What is the limit of this guy? Cosine is continuous all over R, right? 1 plus sine of 4x is also continuous on R, and it is never equal to 0, except one point, when sine of 4x is equal to -1. But when x approaches 0 here, sine of 4x gives us 0, right? Finally, and this is also a continuous function. So the limit of this guy would be the evaluation of this function at the point 0, which will be, be careful, 4 times cosine of 4 times 0, right? Divided by 1 plus sine of 4 times 0. Multiply with cosine at 0 and then square, right? What is cosine of 0? And what is sine of 0? Thank you, Faith. Cosine of 0 is 1, and sine of 0 is 0. Therefore, finally, this fraction becomes four times 1 over 1 plus 0, right? And then multiply with 1. Finally, it will be 4. Okay? So, is it clear now? Very good.
What happened to the E?
Very good question. Here, at this point, we just computed the power of this, right? And here, limit of y, which is the original problems, will be e to the power of this one, right? And we just found it here. This power, the limit, will be 4. It means finally it will be e to the 4. It's a little long, but you see the process, how to deal with these?
Yes.
Very good. So let me write it a conclusion here. This is the process, how we do it. But in conclusion, therefore, the limit when x approaches 0 from the right-hand side of 1 plus sine of 4x to the cotangent of x, which is the limit of, which is e, let me write it, e to the limit when x approaches 0 plus of cotangent x natural log of 1 plus sine of 4x, right? And we just found it here, which is e to the 4. Then this is our solution, because the power here we just computed previously. So do you have any question about this? Are you okay? If you don't have any question, let us move on to the next session, okay? The section 4.5. Now, take a look at the notes I sent you yesterday. If you were in class, you have a physical copy of this. If you will not, download it on Moodle. Here is the process of sketching a graph of any function. So, this is a summary. First, we need to find the domain of the function where it is defined. Okay? For example, if this is the function we have studied together before, the domain of this guy is the whole real lines, right? So it means that the domain of this, in this example, will be from negative infinity to infinity. Okay? We need to find, the next step is to find the intercepts. There are two types of intercepts. First is the x-intercept. Second is the y-intercept. If this is an axis, the axis of any coordinate, the x-intercept are the point that the graph cut the x-axis here. It means at this point, the y value will be 0, or in other words, these x-intercepts are the solution of the function f of x, right? So in order to find them, we solve this equation. The y-intercepts is easier. The y-intercepts are the point where the function cut the y-axis. At this point, you see that what is the value of the x-coordinate of the y-intercepts?
0.
Very good. See that? Then, in order to find them, simply evaluate the value of the function when x is equal to 0. In our example here, what is it?
-5.
Perfect. It will be 0 and -5. Now, you can trace back to the notes of the day before to see the graph, okay? The symmetry, there are two types of function, 3. First, the odd function, even function, and the periodic functions. The odd function, let us talk about the even function first. The even function are the function when we evaluate the value of negative x, give us the same values as f of x. We call it even function, just the definition. So let us check if this is even. In the other way around, we call it the odd function. In our function here, let us check the f of negative x. In our example here, what is it now? F of x is defined as in this formula. F of negative x, it means the input now is the negative of x. Therefore, it is
Negative x. Oh, sorry, you can go.
No, she can go.
6 times negative x squared.
-5, right? Who was that? Who were you?
Faith.
Faith. Thank you, Faith. And Marissa or Catherine?
It was Marissa.
Marissa, thank you. Thank you very much. So here, the power of this is an even number, right? For a even number, no matter whether it is negative or positive, they will be the same. And it is equal to negative of x to the 4th, the same thing. 6x squared minus 5, right? And again, this is exactly the evaluation of the function f of x. So, do you agree with this? From this line to the line below, does it make sense to you?
Wouldn't x to the 4th be positive? Because if you distribute the negative to the negative x, doesn't that make it positive?
No, because here. Now, let us write it here. Look at this. Negative x to the 4th is negative x times negative x times negative x and times negative x 4 times, right? That is the definition of power rule.
Okay, got it.
Very good. That is why negative x to the 4th equal to x to the 4th. And the negative sign in front of that, it would be, yeah, just a negative sign here. So, very good. Then we see that f of negative x is equal to f of x. It means that the properties of even function is it is symmetric with respect to the y-axis. For example, if this is the coordinate for any value of x here and negative value of x here, they will have the same value in the y-axis, right? It is symmetry with respect to the y-axis for even function. So you see it when you do more problems, but now if you don't see it, it is okay. The similar way to test if it is an odd function, then it is symmetric with about the origin. Or the odd function, then you can try with the x cube. Okay, you see it. Another one, asymptotes. The horizontal asymptotes are the limit when x approaches negative infinity and positive infinity. Okay. The vertical asymptote are the point or the discontinuous point, and we want to know, for example, the function 1 over x minus 1. It is undefined at 1, right? This function. So because it is undefined at this point, so the function is not continuous at this point here. We're curious about the function, how it's behaved near this point. And this is the graph of the function. So that is why we need to compute the limit when it approaches the left-hand side and the right-hand side of that point. Okay, the next interval of increase or decrease. How can we do that? Increasing and decreasing. So the first derivative test will tell us about this. Okay, we can make a table as we normally do. F(x) prime. Then we can find the local maximum and minimum. Okay. The next step is concavity points of inflections. Find these points. Then finally, we know all the information about that. We can sketch the graph here. This is the whole process to sketch any function. And this is an example. Okay. Let us do one more thing in more details. Sketch the graph of the function f of x, where f of x is 2x squared over x squared minus 1. Now, look at the notes. What is the first step we should do?
Find the domain.
Very good. The domain. And what is the domain of this?
Is it negative infinity to negative 1?
Very good. So let us find the solution of the denominator, because the denominator should not be 0, right? Therefore, x squared should not be 1, right? And if this is the real lines, the negative 0.1, negative 1, and 1 here, they should not be these two values. So it should be this interval. Okay. Therefore, the domain D will be, Marisa, did you say negative infinity to negative 1?
Yes.
Union with?
1 to infinity.
1 to infinity. Very good. Anything else?
Oh, 1 to negative 1 to 1.
Yes. If you look at the real lines as I do here, it's easier to observe, right? Good job. That is how we can find the domain. Very good. So, what is the next step?
The intercepts.
Perfect. So, Let us find the y-intercept first because it's easy, right? At x is equal to 0. So what is f of 0?
0.
Yes, it is 0. Therefore, the y-intercept is the point A, 0, 0, right? The x-intercepts. In order to do that, we need to solve f of x is equal to 0, or 2x squared divided by x squared minus 1 is equal to 0, right? Yes. Because the denominator on this domain, it will never be 0. We exclude these values. So in order to solve it, what should we do?
Make the numerator equal to 0.
Perfect. Therefore, the only choice is to set the numerator to be 0. Therefore, x will be 2x squared equal to 0. Then x should be, yes, 0. Very good. So, therefore, the y-intercepts, the x-intercept, there's only one point, one solution, right? It would be b at x is equal to 0, 0. Okay? We found the intercepts. Now, what is the next step?
Find the symmetry.
Very good. Find the symmetry. So in order to do that, we need to find we evaluate the value of negative x and see what it is, right? This is our function. Then what is f of negative x? Just
2
replace,
times negative x squared
yes,
over negative x squared minus 1.
perfect. Is it Faith?
Yes.
Thank you. So again, any numbers raised to the power of 2, it will be the same as x squared here, right? And the denominator, this is exactly the function f of x, right? So if it satisfies this, then is it an odd or an even function?
Even.
Yes. Then the even function will be symmetric about the y-axis, right? Okay. Very good. And we know the symmetry. What should we do next?
The asymptotes.
Very good. So the easiest one is the horizontal asymptote, right? Which will which requires to compute the limit of the function when x approaches infinity and the limit of the function when x approaches negative infinity. These are two things we need to do. So the first one, what is it?
Infinity.
Be careful. You may forget about the limit of this. What is the highest order of the numerator?
2.
So we divide both numerator and denominator by x squared, right? Then it gives us limit of this will be review it. Okay, is it clear now?
Yes.
Very good. The similar story, because it is approaching to negative infinity, but we do the same trick here, it finally be 2. So we found the asymptotes already. We're good, right? Then we need to do the vertical asymptote, but I think we can stop today and let us continue doing this on Friday, Monday. So is that okay?
Yes.
Yes.
Can you have more than one symmetry at the same time?
It is a very interesting question. Symmetry with respect to y or x?
Yeah, x and y.
It can only be even or can only be odd, right? Or neither of them. If it is even, then it's symmetry with respect to y. Then that is the only symmetry things we know. But remember about, let me stop recording first. We'll discuss that more.